Okay, we're going to go over section 1.3 right now. Now, section 1.3 puts together what you know from Bohr about sine, cosine, and tangent, the trig functions, and the special right triangles. First of all, the sine, cosine, and tangent. You've done three of these a lot before. You know sine is opposite over hypotenuse. We know cosine is adjacent over hypotenuse. We know tangent is opposite over adjacent. And that's where a lot of you have learned these by SOHCAHTOA, which says exactly that. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So that's the big three trig functions. Now there's actually three more. You may have used these a little bit. These are the reciprocal functions. One is cosecant. And cosecant is the reciprocal of sine. So CSC stands for cosecant. Then secant is the reciprocal of cosine. So SEC stands for secant. That's the reciprocal of cosine. So that's 1 over cosine. So that's hypotenuse over adjacent. You just flip the cosine over. Then cotangent is the reciprocal of tangent. Remember, reciprocal means two things. Reciprocal can mean either flip it over or take 1 over it. So here reciprocal means, if you think of the tangent as 1 over the tangent, or if you think it in terms of the sides, it's adjacent over opposite. So we're going to be using all 6 of those trig functions. So if we were applying that here with this triangle, now when we draw a triangle, we almost always put C as the right angle. So the other two vertices are A and B. Opposite that, like opposite capital A, side A is just a lowercase a. And A always goes across from A. Side B is always across from angle B. Side C would always be the hypotenuse. Now this thing right here, this is a Greek symbol theta. Theta is used a lot for angles. It just traditionally has been. It doesn't mean anything special. It's just a Greek letter. That's all it is. So that letter is called theta. So if we want to find the sine of theta, we know sine is opposite over hypotenuse. So opposite is A, hypotenuse is C. We know cosine is adjacent over hypotenuse, so adjacent to angle theta, adjacent is B, because adjacent means next to, over hypotenuse C. And tangent is opposite over adjacent, well opposite is A, adjacent is B, so tangent's A over B. Again, that's the big three. Now the reciprocal ones, you can just flip those over. Cosecant is the reciprocal of sine, so it's hypotenuse over opposite. Secant is the reciprocal of cosine, so it's hypotenuse over adjacent. And cotangent is the reciprocal of tangent, so it's adjacent over opposite. So that's the trig functions. And you've had that before. Hopefully you remember a lot about that. Now we're going to put in the special right triangles. Now we talked the other day on that boot camp thing about, like, we have a 45, 45, 90 triangle. Now if that's in radians, 45 is the same as pi over 4, because if you remember, pi is the same as 180. So if I put a pi up here, 180 divided by 4 is 45. 180 divided by 2 is 90. So this is a 45, 45, 90. So when you see pi over 4, you think 45. When you see pi over 2, you think 90. So if we take that triangle we looked at the other day, 45, 45, 90, well now that's pi over 4, pi over 4, pi over 2. Same sides, the two legs are 1s. The hypotenuse is a leg times radical 2. A 30, 60, 90 triangle, 30, if pi over 6, if you remember pi is 180, 180 divided by 6 is 30. 180 divided by 3 is 60. 180 divided by 2 is 90. So this is 30, 60, 90. So you'll get used to seeing these, that pi over 6 is 30, pi over 3 is 60, and again pi over 2 is 90. We'll see those ones a lot. So in a 30, 60, 90 triangle, we said opposite 30, so that's pi over 6, is the short leg, that's 1. Opposite 60, or pi over 3, is the long leg, which is the short leg times radical 3, and the hypotenuse is the short leg times 2. So if we go down here and start filling this table, and these are things that we'll do, like 30 degrees, well, in radians, that's pi over 6. If we go up to this figure, the sine would be of pi over 6 is opposite over hypotenuse, that's 1/2. The cosine is adjacent over hypotenuse, that's radical 3 over 2. The tangent is opposite over adjacent, that's 1 over radical 3. And it's okay to leave the radical 3 on the bottom. If you don't like it there, you can flip this. You can take top and bottom times radical 3. That's the same as radical 3 over 3. Either one of those is a fine answer. Then the 3 reciprocal ones, you just flip those over. Cosecant is the reciprocal of sine, so that's 2 over 1. Secant is the reciprocal of cosine, so it's 2 over radical 3. Again, if you don't like the radical on the bottom, you can take top and bottom times radical 3, which makes it 2 radical 3 over 3. And the cotangent is reciprocal of tangent, so that's radical 3 over 1. "45 degrees, that's the same as pi over 4. So if we look at that triangle, sine is opposite over a hypotenuse, 1 over radical 2. Again, that's fine. If you want to rewrite it as radical 2 over 2, it's the same thing. Cosine is adjacent over hypotenuse, so that's 1 over radical 2. Or radical 2 over 2 if you want. And tangent is opposite over adjacent, so that's 1 over 1, which is 1. Then the reciprocal functions, cosecant is the reciprocal of sine, so that's radical 2 over 1. Secant is the reciprocal of cosine, that's radical 2 over 1. Cotangent reciprocal of tangent, so it's just 1. Then a 60-degree angle. Well, 60 is pi over 3. Again, to double check that, remember pi is the same as 180. So 180 divided by 3 is 60. So we go back to this triangle. Now we're going from the 60-degree angle. So sine is opposite over hypotenuse, radical 3 over 2. Cosine is adjacent over hypotenuse, 1 over 2. Tangent is opposite over adjacent, radical 3 over 1. Cosecant is the reciprocal of sine. So if we flip that over, it's 2 over radical 3, or if you want to write it as 2 radical 3 over 3, that's fine. Secant is the reciprocal of cosine, so it's 2 over 1. Cotangent is the reciprocal of tangent, so it's 1 over radical 3. Again, if you don't like it like that, you can change it to radical 3 over 3, same thing. I am perfectly fine with leaving those as 1 over radical 3. For what we do, a lot of times that's easier. Because when we start flipping it over, it makes it easier. You don't have to rationalize or de-rationalize all the time. All right, now these last ones are called quadrantal angles. Quadrantal angles are angles that land right on one of the quadrant lines. So like 0 is a quadrantal angle. 90, 180, 270, 360. Or in radians, still 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are called quadrantal angles. For those, we use just points for those. And I wrote them, if you can see them on here. Over here at 0 or 360, the adjacent side is always 1. The opposite is always 0. Up here at 90 or pi over 2, the adjacent is 0. The opposite is 1. Over here at 180 or pi, the adjacent is negative 1. The opposite is 0. Down here at 270 or 3 pi over 2, the adjacent is 0. The opposite is negative 1. And on these, the hypotenuse is always 1 on all of these. The hypotenuse is always 1. So if we're at 0 or 360, well, 0, 360, that would be 0 or 2 pi in radians. Sine is opposite over hypotenuse, so that would be 0. Here we said the opposite is always 0. So that's 0 over 1, or 0. Cosine is adjacent over hypotenuse. The adjacent here is 1 over 1. Tangent is opposite over adjacent, so that's 0 over 1, or 0. Then the reciprocal functions. Cosecant's the reciprocal of sine, well, 1 over 0. Remember, you can't divide by 0, so that one's undefined. Secant is the reciprocal of cosine, so it's just 1. Cotangent is the reciprocal of tangent, so it's 1 over 0, which again is undefined. Make sure you never leave an answer as 1 over 0. You need to say that it's undefined. Same way, don't leave an answer as 0 over 1. We know that's 0. All right, let's move up to 90. Well, up at 90, the adjacent is 0, the opposite is 1. So 90, we know in radians is pi over 2. Sine is opposite over hypotenuse, so 1 over 1. Cosine is adjacent over hypotenuse, so 0 over 1, which is 0. Tangent is opposite over adjacent, which is 1 over 0, or undefined. Then the reciprocals. The reciprocal of cosecant is the reciprocal of sine, so that's 1 over 1, which is 1. Secant is the reciprocal of cosine, so that's 1 over 0, which is undefined. And cotangent is the reciprocal of tangent, which is 0 over 1, or 0. 180. Well, over here at 180, there the adjacent is negative 1, the opposite is 0. We know 180 is the same as pi. The sine would be opposite over hypotenuse, 0 over 1, which is 0. The cosine would be adjacent over hypotenuse, which is 1 over 1. The tangent is opposite over adjacent, which is 0 over negative 1. I'm sorry, I did that wrong. Excuse me. I forgot my negative here. Sorry about that. So here, that's adjacent over hypotenuse, so that's negative 1 right there. Sorry about that. Then cosecant is the reciprocal of sine, so that's 1 over 0, which is undefined. Secant is the reciprocal of cosine, so that's 1 over negative 1, which is negative 1. And cotangent, the reciprocal of tangent, which is negative 1 over 0, or undefined. Then the last one, finally. 270 is down here. Well, in radians, that's the same as 3 pi over 2. Because we go pi over 2, 2 pi over 2, 3 pi over 2. Now down here, the adjacent is 0. The opposite is negative 1. So sine is opposite over hypotenuse. So negative 1 over 1 is negative 1. The cosine is adjacent over hypotenuse, so 0 over 1, which is 0. And the tangent is opposite over adjacent, negative 1 over 0, which is undefined. Then the reciprocals. Cosecant, again, is the reciprocal of sine. 1 over negative 1 is negative 1. Secant is the reciprocal of cosine. 1 over 0 is undefined. And cotangent is reciprocal of tangent. 0 over negative 1, which is 0. All right? We don't usually do all of those at once. We were just going over it, got off the page here. Hopefully didn't fall asleep during all those. That goes through all the ones we're going to use. Now this next part is just using a calculator. So here on my graphing calculator, see that my batteries are low. Like here now what we're doing radians, boy, you really got to double check. One of the maybe the newer calculators don't do it, is you never know which one you're in, so you have to double check. So if I go to mode, notice down here, the third one down, it can be radians or degrees. Like here, I want to be in degrees, so I'm okay there. But you want to check that a lot. Nothing more aggravating than do a whole bunch of problems and find out you're in the wrong mode. So sine of 26.2, we just punch it in just like it is. Sine of 26.2, hit enter. I get 0.4415. I tend to always put trig functions, trig values, into 4 decimal places. Just when I went to high school, that's the way it always was in the book. We didn't have calculators back then, so this was printed in a book, and it was always to 4 decimal places. So that tends to be what I do. Now notice this one. If you see here, there's no degree symbol. The rule is if you don't see a degree symbol, it's in radians. So we need to go back to mode, go down to that third line, and highlight radians. So it's highlighted now. Now, we're going to do that. The tangent of 3.79. So if you don't see a degree symbol on there, it is radians. So the tangent of 3.79 is 0.75769. So 0.75769, I could round that off to 0.7577. Okay? Those are pretty straightforward. Just make sure you check degrees radians. The reciprocal functions are a little trickier. Like if you want to find secant, there is no secant button on your calculator. So if you want to find secant, you need to think of it as the reciprocal of sine, and that's what I say in my head. The secant of 135 is the reciprocal. The reciprocal means I put 1 over the whole thing. So it's the reciprocal of the cosine. So that's what we're going to do on our calculator. So I need to change my mode back to degrees. And now I'm going to do just what it says, the reciprocal. So 1 divided by the cosine of 135.2. The reciprocal ones are really tricky. You have to be careful with those. It's easy to do them in the wrong order. I get a negative 1.4093. I'm going to just add another one of those reciprocal ones like here. Like what if I want the cosecant of 25, and this is in radians. So cosecant is the reciprocal, so I start with that, the reciprocal of sine. Now notice there's no degree sign over here, so I need to go back to radians. So change my mode to radians. You can see that on there. Now I'm going to take 1 divided by the sine of 25. And I get negative 7.5556. So negative 7.5556. One last one, notice this is in degrees, minutes, seconds. We converted that the other day. We're going to do the same thing here. So we're going to be doing the cosine of 87 plus, we take the minutes, 42 divided by 60, plus the seconds, 31 divided by 3600. So I'm just going to do all that once on my calculator. I need to go back to check my mode. I need to be in degrees. So I hit the cosine of 87 plus 42 divided by 60 plus 31 divided by 3600. And I get 0.03998, which rounds to 0.04. Okay? Let's turn to some application problems. Now, to do these application problems, it's going to be kind of a long video. So if you wanted to like stop right there and do some practice problems, that would be a good time for that. Now, first, to do some application problems. A lot of application problems deal with angle of elevation and angle of depression. Angle of elevation, most students don't have a problem with that. It's from horizontal up. So it's like if you're right here, here's the ground, and you're looking up at a building. The angle of elevation is from horizontal, so here's horizontal here. If we go up to the angle of the building, this is the angle of elevation right there. So it's from horizontal up. The one students have a lot of trouble with is angle of depression. I see that in the wrong place all the time. It's just something about it. Angle of depression is the angle down. So let's say you're on top of the building now. Here you are here, and you're looking down here. You need to start from horizontal. So you start here, and then you look down to there. This is the angle of depression right here. Students will always put it right here. One of the sides of the angle, see each angle has two sides. One of the sides has to be horizontal. If you put it here, one of them is vertical. That never happens. So there's the angle of depression right here. So if we're doing an angle of depression problem like this one, it says, and we'll draw a picture. This is always helpful to draw a picture. So here's the Washington Monument. We're going to go back away from the Washington Monument 115 feet. This problem's not worded very good, but it should say the man is up on top of the Washington Monument. So from here, he measures the angle of depression to right here to be 78.3. So that means angle of depression, you go from horizontal and then down to there. So this is the angle of depression right here. I tried to say this many ways possible, but it never seems to be true. The angle of depression never, ever, ever, ever goes there, never. So that's the picture we have. So there's a couple of different ways to do this. You could say, since this angle is 78.3, if you remember your geometry, these are parallel lines, here's a transversal. These two angles here are called alternate inferior. So this angle is also 78.3 degrees. So now we want to find the height of the monument. Well, that's this side right here, so I'll call that H for height. Now we look at that picture and say, okay, from this angle, which two sides are we dealing with? Well, from this angle, we know the adjacent side. We're trying to find the opposite side. Which trig function has opposite and adjacent? Well, that's tangent. So we're going to say the tangent of 78.3 equals opposite over adjacent. There's our equation. To solve that, we want to get h by itself, so we multiply both sides by 115. And then we just finish it on our calculator. So we take 115 times the tangent of 78.3. And I get 555.3 feet tall. Okay. Next one, another application problem here. Find the length of this skateboard ramp. Now, it's you have to decide what the length means. To me, I would call this the length here. So there's our right angle. So again, from our angle, which two sides do we know? From this angle, we know the opposite side is 4. We're trying to find the hypotenuse. Which trig function sounds like opposite and hypotenuse? Well, that sounds like sine. So the sine of our angle, 18.4, equals opposite, which is 4, over the length, which is L. Now, these problems are always the worst when the L is when the variable is on the bottom. So we're going to multiply both sides by L first. We've got to get it out of the bottom first. Then, now this side looks like this. We want to get this to the other side. Well, that's times, so we're going to divide. So this is what we'll end up doing on our calculator. You can always think of it as these two things really just switch spots. The L and the sine of 18.4. And then we just do that on our calculator. So we take 4 divided by the sine of 18.4. And I get 12.67, so we could say that's 12 feet. If this problem, if you interpreted the length of the ramp as this side down here, then you would have said, okay, from this angle we have opposite, and we're trying to find adjacent. You would have said the tangent of 18.4 equals opposite over adjacent, and solve from there. So that's another type of problem you'll see in applications. A third one is bearing. Bearing gets a little bit confusing sometimes because it's measured two different ways and it's not standard form like we just learned. Bearing is the direction you're going. You'll see here like a plane especially will say, well, what bearing do we take? A ship on the ocean takes a certain bearing. There's two ways to measure bearing. One way is from north, measured clockwise. If they just give you a number like this and they say it's bearing, we learned standard form. Well, this is not standard form, which I'm sorry that's confusing, but it's just the way it is. It's measured from north clockwise, so 32 degrees. We start from north, which is right up here. So here's north. And we go clockwise, so we're going this way 32 degrees. So that would be a bearing of 32 degrees, or 164. Again, we start up here from north. We don't start from over here. We start from north, and we go around 90. Well, 180 would be clear to here, so we're going to stop a little short. That would be a bearing of 164 degrees. 229. Again, start from north and go clockwise. 90, 180. Well, the next one would be 270. We only want 229, so somewhere in here would be 229. Then 304, we start here. Again, start here. Sorry, I got myself confused. Start here and go around 90, 180, 270. So 304 is going to be a little bit farther. There's 304. So that's one way of doing that. That's when it's just a number, no letter. You start from north and go clockwise. The other way is a little more descriptive because it tells you two directions. Like here, north 42 degrees east. So it tells you to start from north. So if we were doing this, and here's north, so we start from north. Well, that's north. This is east over here. So we're going to go 42 degrees east. So we're going to go right or clockwise 42 degrees. Or here it says start from south. Well, south is down here. East is still here. So this means we start from south and go east 31 degrees. So we're going to go to the right towards east 31 degrees. Or here it says start from south and go 40 degrees west. So going here's south, west is over here, right? Because this is the way the directions go. So start from south and go 40 degrees to the west. We're going to go 40 degrees this way. Or north 52 degrees west. Start from north and go west. So here's north, here's west. Go 52 degrees. So that's the two types of bearing. Now to do a problem with that, we've got the hardest part of these problems is drawing the picture. Because you've really got to be careful. Coming a long video. So it says radar stations A and B are on east-west lines. So we'll start with that. A and B are east and west of each other. It says A is to the west, so it's over here. There's our 2 points. It says the distance between them is 3.7 kilometers. Then it says A detects a plane at C on a bearing of 61. Remember, when the bearing is given like this, we start from north and go clockwise. So station A, so we start from station A and go north. We're going to go clockwise 61 degrees. So somewhere over here. From station B, the same plane is the bearing of 331. So go over to B, draw north. 331 is going to be 90, 180, 270. So 331 is going to be over here somewhere. This is our plane C. We want to find the distance from A to C. So we're trying to find this side right here. So I can call it B or X, whatever you want to call it. Now first in that triangle, we need to find our angles. Well, if this is north, this is east. If that's 61, these have to add up to 90. So this one has to be 29 degrees. Here, as we were going around, we went 270 to get to 331. That's another 61. Well, 29 and 61 is 90, so this is a right angle. So now we look at our triangle. We can use either of these angles we want. It makes no difference at all. Let's say we use 29 here. Look which sides we know. We know the hypotenuse, because that's the hypotenuse, and we're trying to find adjacent. Well, that sounds like cosine. So we say the cosine of 29 equals adjacent over hypotenuse. And we just do that on our calculator. So, I'm sorry, before we need to get the B by itself, so we're going to multiply by 3.7. So 3.7 times the cosine of 29. I get 3.236, so we could say 3.2 kilometers. Now we have another one here. That's just because this is the other type of bearing. I wanted to make sure we did both types of bearing. So here it says the bearing from A to C is south 52 east. So if we start with A over here somewhere, it's south 52 east. So we start from south, so draw a south line. East is to the right, so 52 degrees east. Somewhere out here is point C. It says the bearing from A to B is north 84 east. So we're still starting at A, so this is A to B. Now we're starting from north, and we're going 84 degrees east. So here's east is still to the right, so somewhere over here. The bearing from B to C, so here's B out here. The bearing from B to C is south 38 west. So from B we go south, west is to the left, so left 38 degrees. So where these intersect, that's point C right there. Now it says going 250 miles an hour for 2.4 hours. Well, we need a distance. Well, we know rate times time equals distance. So our distance is 250 times 2.4, which is 600. So that plane flies 600 miles. We want to find that's from A to B. So this distance right here is 600. We want to find this distance over here, A to C. So I'm going to call that side B. Now, if you look at this triangle, somewhere in there, there needs to be a right angle for us to do this. This can get a little complicated, but here, these three angles here have to add up to be 180 because they form a line. Well, 84 and 52 is 136. If we subtract that from 180, we get 44. So this angle right here is 44 degrees. This angle right here is our right angle. My picture doesn't exactly look like it. So we're trying to find this side. So looking again from this angle, we want to find the adjacent. We know the hypotenuse, so we say cosine of 44 equals adjacent over hypotenuse. And then we can just multiply to find our answer. So 600 times the cosine of 44. 431.6 miles. Okay, I know that's a lot of stuff in one. That was a long video. It'd be a good idea to stop that. We're past that now. But that's it for 1.3 and application problems.